A machine was shown a piece of cloth and told nothing about what it was looking at. No history, no religion, no context. Just pixels. And when the analysis finished, the researcher staring at the output realized something strange. The numbers did not behave like paint, and they did not behave like nothing either. They behaved like information. That single detail is why, after more than 600 years of argument, the most famous linen cloth in the world is once again at the center of a scientific debate. Except this time, the debate is being run through neural networks and statistical models instead of magnifying glasses. The Shroud of Turin is a 14-foot strip of linen, kept in a cathedral in northern Italy, bearing the faint front and back image of a bearded man along with reddish-brown stains that forensic analysts have identified as human blood. For centuries it has been venerated by many as the burial cloth of Jesus Christ, and dismissed by others as an elaborate medieval production. Both camps have had scientists on their side. Both camps have had moments where the evidence seemed to break decisively their way. And in 2025, both camps got new ammunition from the same source: artificial intelligence. The most significant of these new studies came from Thomas McAvoy, a chemical engineer and professor emeritus at the University of Maryland, published in the International Journal of Archaeology in June 2025. McAvoy did not photograph the shroud himself. Instead, he went back to the archive left behind by the 1978 scientific investigation of the cloth, a project known as STURP, the Shroud of Turin Research Project, and pulled out a category of images that had never been fully mined for information: ultraviolet fluorescence photographs. When linen is struck with ultraviolet light, certain molecules in the fibers glow faintly, and the intensity of that glow can reveal chemical and structural differences invisible under ordinary light. McAvoy applied a machine learning technique called principal component analysis, a method used across fields from genomics to finance to find the handful of underlying patterns that explain almost all the variation in a huge, messy dataset. It is, in effect, a way of asking a mountain of numbers what story they are actually telling once you strip away the noise. What the algorithm found was that nearly all of the meaningful variation in those ultraviolet images collapsed into a single dominant pattern, and that pattern tracked closely with the raw brightness of the image itself, meaning the chemical and structural differences in the cloth are not scattered randomly, they are organized in a way that mirrors the body image. McAvoy's interpretation, building on decades of prior hypotheses from other shroud researchers, was that this organization is more consistent with some kind of radiant energy event than with a substance being brushed, rubbed, or otherwise applied to the surface. He is careful, in his own writing, not to claim he has identified what that radiation was or proven its source. What he argues is narrower and more interesting: that the pattern recognition tools, working blind, kept sorting the image into the same bucket that earlier physicists like John Jackson and Eric Jumper had proposed back in the 1970s, when they first noticed something odd about how the image behaved under a device called a VP8 analyzer. That earlier discovery is worth explaining, because it is the reason serious scientists have taken the shroud seriously for 50 years, regardless of what they personally believe about its origin. A VP8 analyzer was built to convert the brightness of an image into a three-dimensional relief map, the way NASA might use it to translate satellite photography into terrain data. Feed it an ordinary photograph, a painting, or a portrait, and the output is a meaningless, flattened distortion, because in normal images brightness encodes lighting and artistic choice, not physical distance. Feed it an image of the Shroud of Turin, and the output resolves into a coherent three-dimensional human form, as though the brightness of the image at every point corresponds to how far that part of the cloth would have been from a body underneath it. That relationship between light intensity and distance is not something a painter in any century has ever had reason or ability to encode, because painters paint what a scene looks like, not how far away it is. McAvoy's 2025 work used modern statistical tools to quantify and confirm that this distance-encoded structure is real and consistent across the ultraviolet dataset, not an artifact of how the 1978 photographs happened to be lit. None of this, on its own, tells us who made the image, or how old the cloth is. And it is worth being honest about the parts of the story that often get flattened into certainty by documentaries and headlines, because the actual scientific record is messier and more interesting than either definitively Jesus or definitely a fake. Start with the blood. Chemist Alan Adler, working with the original 1978 samples, reported finding elevated bilirubin in the reddish stains, a breakdown product the body produces in larger quantities under severe physical trauma, and one that some researchers have argued could help explain why the stains still appear reddish rather than the black and brown that old blood typically turns. This finding has been cited for decades as evidence that the blood is both genuine and consistent with a body that suffered extreme beating before death. It is real, published research. It is also not the final word. Other scientists have pointed out that iron oxide pigments, certain dyes, and environmental factors can also produce reddish stains on aged linen, and that confirming the exact chemistry of centuries-old, degraded material is extraordinarily difficult. The honest summary is that the blood evidence is genuinely intriguing and has never been fully explained by the It's Just Paint camp, but it has also not been independently replicated and confirmed to the standard that would end the argument. Then there is the negative image, which remains one of the strangest single facts about the shroud regardless of which side of the debate you're on. In 1898, an Italian lawyer and amateur photographer named Secondo Pia was given permission to photograph the cloth using the glass plate technology of the era. When he developed his negative in the darkroom, he found himself looking at what appeared to be a positive photographic image, a clear, detailed, almost lifelike face, with the light and dark values reversed from what appears on the cloth itself. In other words, the shroud image behaves as though it is already a photographic negative, one that only resolves into a natural-looking positive when captured on film and reversed a second time. Photography, and the entire concept of a tonal negative, did not exist before the 19th century. Whatever process put that image on the cloth, it produced a light-dark relationship that a medieval workshop would have had no framework, technique, or reason to attempt, since there was nothing to check it against and no viewer who could have appreciated the effect without a camera of their own centuries later. The image's physical structure adds another layer to the puzzle. Researchers using electron microscopy in the 20th century found that the coloration exists only on the very topmost fibers of the linen threads, in a layer estimated at a few hundred nanometers thick, a small fraction of the width of a single human hair, with no penetration into the thread and no capillary staining of the kind you'd expect from a liquid pigment soaking into cloth. It is, essentially, a surface discoloration so shallow it borders on the two-dimensional, distributed unevenly across individual fibers in a way that some researchers have compared to a half-tone print, where the density of small dots rather than continuous shading creates the illusion of a smooth image. Half-tone printing, like photography, is a 19th century invention. The 1978 STURP team's formal conclusion, after 5 days of continuous on-site testing with equipment borrowed from national laboratories and the Air Force, was that the coloration is not paint, dye, pigment, or scorch, but a chemical alteration, oxidation and dehydration, of the cellulose fibers themselves. That conclusion has held up for nearly 50 years without a competing explanation from mainstream materials science, which is precisely why the mystery has stayed alive in respectable scientific journals rather than fading into pure folklore. But 2025 didn't just produce evidence pointing toward the extraordinary. It also produced a serious piece of research pointing the other way, and any honest account of what AI found has to include it. A study published in the journal Archaeometry in 2025 by researcher Cicero Moris used 3D digital modeling and simulation to test how a human body draped in cloth would actually produce an image, versus how a shallow bas-relief carving, a sculpted panel, rather than a real three-dimensional body, would produce one. Moris's model suggested that a real body wrapped in cloth would generate image distortions and doubling effects that don't match what's actually seen on the shroud, while a flat, or low-relief surface pressed against or radiated onto the cloth produced a result closer to the shroud's actual proportions. His interpretation is that the image's characteristics are more consistent with contact against a sculpted or engraved surface than with drapery around an actual corpse, which would support a medieval origin using techniques known to exist at the time. That study doesn't disprove the earlier findings about the negative image or the distance encoding effect, but it's a serious, peer-reviewed counterpoint. And it's a reminder that AI is not a single verdict-generating oracle. It is a tool, and different researchers pointed it at different questions and got results that pull in different directions. The 1988 radiocarbon dating remains the center of gravity for this entire debate, and it deserves to be described accurately rather than dismissed or oversold. 3 laboratories, Oxford, the University of Arizona, and the Swiss Federal Institute of Technology in Zurich, independently tested small samples cut from a single corner of the cloth and dated the flax to somewhere between 1260 and 1390 CE, comfortably within the medieval period. It was a rigorously conducted, peer-reviewed, internationally cross-checked test, and it remains the strongest single piece of evidence for a medieval origin. It is also true, and worth stating plainly, that questions have been raised about whether that one sampled corner, a heavily handled area, repeatedly touched by clergy and pilgrims and previously mended after fire damage, was representative of the cloth as a whole. Chemist Raymond Rogers, who had worked on the original 1978 team, published research arguing that the threads from the dated corner showed cotton fibers and dye chemistry inconsistent with the rest of the shroud, suggesting the sample may have included medieval reweaving or repair work rather than the original fabric. That claim has been debated rather than settled. Some scientists find it compelling. Others argue the radiocarbon result should stand until a fresh, multi-location sampling is carried out, which the custodians of the shroud have so far not permitted. The fair way to describe where things stand is this: the radiocarbon evidence for a medieval date is real and has never been overturned by a repeat test, but legitimate, published concerns about sample representativeness mean the question isn't as fully closed as either side likes to claim. There's one more piece of physical evidence worth including, because it doesn't depend on AI or advanced imaging at all, and it has quietly nagged at art historians for a long time. Medieval crucifixion art, painting after painting, sculpture after sculpture, shows nails through the palms of the hands. That was the standard visual convention across Christian Europe for centuries, because it read clearly to viewers and matched the wording used in translations of the Gospel accounts. The wounds on the shroud, however, are located at the wrists. Modern anatomical and forensic studies of crucifixion have noted that the palm alone likely cannot support a hanging body's weight without the tissue tearing, while the wrist's bone structure could plausibly bear it. If the shroud were a medieval artist's invention, it broke from every visual convention of its own era on a detail that requires modern forensic reasoning to even appreciate as significant, which is either a strange coincidence, an unusually well-informed forger, or evidence the image wasn't invented by an artist working from imagination at all. None of the AI studies from 2025 overturned or added much to this particular observation. It's older, but it still sits awkwardly inside the obvious forgery theory. So where does that leave things? After running the most famous disputed relic in the world through some of the same machine learning tools currently reshaping medicine, physics, and archaeology. Not at a final answer, and any video that tells you otherwise is selling certainty the actual research doesn't support. What the 2025 AI analyses actually did was sharpen the existing mystery rather than resolve it. McAvoy's pattern recognition work reinforced, with new statistical rigor, that the image encodes something more structured than a painted or dyed surface, echoing the old VP8 distance mapping anomaly from the 1970s. Maurice's 3D modeling pushed in the opposite direction, arguing the geometry fits a sculpted relief better than a real body. Both papers passed peer review in 2025. Both used legitimate computational methods. Both reached conclusions that flatly disagree with each other, which is a pretty good description of where shroud research has always lived, not because scientists are careless, but because the object itself keeps generating data that doesn't cleanly fit into either the medieval forgery or burial cloth of Christ box. What can be said with confidence is this: Whatever produced the image on the Shroud of Turin used a mechanism that has not been fully replicated, identified, or explained by any laboratory, ancient or modern. The blood chemistry, the negative image effect, the fiber-thin depth of the coloration, and the distance-correlated brightness are documented, published, testable observations, not internet folklore, while the radiocarbon date, the sample representativeness debate, and the newer sculptural modeling are equally real and equally documented reasons for caution. Artificial intelligence didn't settle the argument between believers and skeptics in 2025, and it's worth being suspicious of anyone who tells you it did, in either direction. What it did was give researchers a sharper set of tools to ask old questions, and in doing so, it turned up patterns that both sides are still arguing about, which, for a 600-year-old mystery, might be the most honest outcome anyone could have expected. The Shroud of Turin remains exactly what it has been since Secondo Pia first developed that photographic plate in 1898, an object that keeps returning a we don't fully know from every new generation of technology aimed at it. The 2025 machine learning studies didn't close that gap. They mapped it more precisely than anyone had before, and left it standing wide open for whatever comes next.